Thank you very much. Welcome to our short talk on implementing access control in AEM EDS. I'm Ben. I'm the founder of Hit the Code, and I've worked on AEM for more than 10 years. I'm here with Ratko.
Hello, everyone. I'm Ratko, and for the past few years, I've been working on Adobe Cons sites and migrating them to EDS.
So Ratko and I have been working on migrating an Adobe partner portal to EDS in the past few months. And we get all the great performance from EDS, but how do we protect these pages when we serve them from the edge? Because we have different partners, different partner levels, and they should see different things. So we propose a solution to do this using edge functions, and that's what we'll talk about in the next few minutes. Our requirements are pretty much those of a classical AEM CUG. We want to restrict access based on the user's login status, and we want to protect resources based on different user groups. Of course, we want to keep the perfect EDS performance, especially for the public pages. The public pages are the ones that we want to see in the search engines, so they are SEO relevant, and we optimize for them. And of course, we want to be cost effective. Our solution consists of 3 main points. The first is really low tech. We can use an HTTP header to actually specify the access per directory or resource. We chose the name permissions protection header, but you can choose any other name. Authors can use the default EDS headers configuration and set this header per resource. We then check this header in an edge function, and if it's public, we just serve it. If it's protected, we invoke an access provider. The access provider authenticates the user once per session, and on every subsequent request, we authorize the user's access to the resource. This is what this looks like in a graphical representation. The browser sends a request, CDN forwards it to EDS. In the response, we add our header, and on the response processing on the CDN, we authenticate and authorize and send back the appropriate response. One detail is that we want to make sure no one accesses EDS directly, but that's a standard feature that EDS has. Let's take a closer look at our edge function. So when the client sends a request, the first thing is we retrieve the EDS document, and then we immediately check if it's a public one. If it's a public resource, we directly can serve the resource with HTTP 200. If it's protected, we need to check if the user is signed in. If not, he or she needs to go through the authentication flow and basically start again from the left until we have a signed-in user. And now we can check if the user is authorized. We invoke our access provider and send back the appropriate response. An important part to our solution is an HTTP-only cookie that we generate on the access provider. We generate this when the users first visit our page, and we encrypt data there. We encrypt the user's login ID, and we encrypt all data that we need to later authorize the user. So when the user comes back, we just read that cookie, we decrypt it, and we can perform all the authorization needed just from this one cookie. If the cookie becomes invalid, if it's expired, or if somebody tampers with it, we remove it and try to regenerate a new one from our IDP. It's really important that this cookie is HTTP only, because that increases the security significantly. But it means that we cannot use it to display user data on the website. So if we need to personalize the website as well, then we need to use a separate cookie or different mechanism altogether for this. And now it's time for a live demo. I'm handing over to Ratko.
Thank you, Ben. So we prepared the live demo. For the demo, we used, of course, EDS. For our CDN, we used CloudFlare, and for our very simple authentication and authorization service, we used a couple of Adobe I/O runtime actions. If you want to follow along, our demo is live on apollopol.com, and for all the links to the repos and everything that we used in the demo, you can find it in this URL or by scanning the QR code. Okay, let's start. Yeah, so first, we are greeted with our homepage that is also a public page and accessible by everyone. In addition to this, we have two protected pages with two different protection levels, member page and a secret page. Right now, I'm not signed in, so let's try to access the member page. Because I'm not signed in, I will be redirected to the sign-in page, and here I can sign in using any name I want. I will use my own. After this, we have access to the member page. As you can see, it says Hello Ratko, and this page is accessible to all logged in users. In the top right corner, you can see the protection level for this user, which is member. And this user can also go to the home page, which is public, of course. But if you try to access the secret page that has different protection level, we'll be greeted with an error message that says that we don't have an access to this page. Okay, let's sign out and try to go to the secret page again. We are redirected to the sign-in, and if you read closely, user Jack has access to the secret page. I'm gonna sign in with user Jack, and now we have reached the secret page that is accessible only to the username Jack. And if you check the user protection level again, it says secret, and basically that's the reason why he can access this page and the other user couldn't. He can also go to the member page and to the home page, of course. Okay, now let's see what happens in the background and show some things that Ben mentioned that we use. We are going to start with the cookies. So as you heard, we have two cookies. One is the HTTP only cookie that is basically encrypted user data that we then use on authorization service to verify the user and to see if he has access or not to the page. Second one is the JS readable cookie that we can use on a client side to personalize our pages, like this hello message that contains the username, and in the navigation we have user protection level. These cookies are also used on Cloudflare, so we can know if the user is signed in or not. And if there is no cookies, we know that user is not signed in, and redirect him to the sign-in page if he requests the protected page. Okay, so if I sign out now, we delete all the cookies. I'm not signed in anymore, and if I try to go to the protected page again, I am on the sign-in page. Now, let's talk about headers and how we use them. So, as you heard, we use them for defining if the page is protected and what's the protection level of the page. If we inspect closely our response headers for our home page, we can find our protection header here that has a value of public for this page. For the member page, it has a value of member, and for the secret page, it is a secret. And if you remember, Jack user had a secret protection level, and that's basically the reason why he could access the secret page. Now, let's see how this is authored and basically added to our pages. So here, on this Google Drive, we have a pretty simple EDS setup with all the pages that I showed you. So we have home page, forbidden page, secret page, and member-only page in these folders. But the most interesting thing for us here is this .helix files folder that contains this header Excel document. In headers Excel document, we define our custom header and also on what pages we want them to appear. So here we have two columns. First is the URL column, where we define the path to the page or pages that we want to see the header. There are two ways. We have like exact pathway, which will target only a specific page and return the header to only that page, or we can use this like wildcards. And what this does is that anything inside the member-only folder will have the member protection level. Same goes for the secret folder, and for forbidden, again, we have like exact path, and this will be only applied for that page. In a second column, we have our custom header. As you heard, it was called protection. First row is reserved for the name of the header. Then we have our values that are then applied to the pages based on the first column. So, quick summary. Cloudflare has a header information which tells us what's the protection level of the page. Also, if user is signed in, it will have the user information. Those two information are then passed to our authorization service, where we verify the user and decide if user has access or not. Then that is returned to the Cloudflare, and based on the result, Cloudflare will either serve the page or serve the error page. That will be all for the demo. Again, if you want to check out our resources and code, you can do it by visiting this URL or scanning the QR code. Thank you, and now, Ben, you can take over again.
Thank you, Ratko. And yeah, try it out on apollopoll.com and let us know if it works for you.
Yeah.
I'm going to walk you quickly through some code. I guess most of you are familiar with EDS by now, but maybe not so much with the edge functions. I will show you some pseudocode for CloudFlare Workers and for Akamai EdgeWorkers. In a CloudFlare Worker, every request passes through the fetch function. And from there, we have a lot of possibilities, but also we need to take care of a lot of things ourselves. So for example, first, we need to check ourselves if the resource is already in the CDN cache. If not, we fetch it actively from the origin, which is EDS in this case. And once we have successfully fetched it, we push it into the cache. Only at this point, we can finally check if the resource is protected. And if it is protected, we validate the user's access and return the appropriate response. The Akamai EdgeWorker code looks much shorter. Akamai EdgeWorker provides us with a number of callbacks where we can hook into the request response flow. And the one we want to use here is the on-client response. At that point, Akamai has already taken care of all the caching of retrieving the resource from the origin, and we already have the response, including our header. So the only thing we really need to do is we need to check if the resource is protected. If yes, validate user access and respond with the appropriate response. An important topic to talk about is caching. In a typical EDS setup, we have at least 3 caching layers. We have the browser cache, we have the outermost CDN, so Akamai or Cloudflare, and we have EDS, which itself has a CDN cache. So I'm going from right to left this time. Both the EDS cache and the outermost CDN cache, we can fully leverage without worrying about enforcing access, because we enforce the authorization after we retrieve the documents from the cache. So the only thing that's important is that the documents there are fresh, that the content itself is up to date, and when the author makes a change, these caches get flushed. Apart from that, for us, we retrieve the document from cache, we check our header, and then we send back our response. Good. Yeah. So the tricky part is the browser caching. We have a simple recommendation from our experience: cache only the public resources. If you, for some reason, need to also cache protected resources, this can get really tricky in an SSO setup. I have a question for you. I assume everyone here has one Adobe ID. How many of you have more than one Adobe IDs? Yeah, that's great. I hope to see that result. I have at least 3, and some of them connected to multiple organizations. And I have to confess, when I switch between Adobe IDs, I do not always close the browser in between. So for us, this means we cache a resource in the browser, but then when the user later refreshes the page, he may actually read it from the browser cache, but he's maybe logged in with a completely different Adobe ID that does not have access to this. So it's important that we pass through our edge function on every request to a protected resource. There seems to be the perfect solution. It would be the cache control must revalidate header. But for some reason, we did not get it to work. Both Akamai EdgeWorkers and CloudFlare Workers have some limitations, and we were not able to actually get this to work. I have put some details in the appendix. If you're interested, read through it and discuss it with us. Yeah, we're also, of course, open for any suggestion on how to get this to work. It's time to start with the summary. For security, it's very important that we enforce authorization after retrieving data from the EDS or CDN cache. It's important that we perform authorization based on an encrypted and HTTP-only cookie. And it's important that we configure caching, especially browser caching, very carefully. For performance, we literally have no computation on the edge for the public pages, and the public pages are the ones that are SEO relevant. So that's how we can keep the great EDS performance. And to be cost effective, we offload as much processing as possible to our access provider, especially all the cryptographic operations should be offloaded. That was it. In summary, implementing gated access in EDS has really worked well for us so far. We're not live yet. I hope I still say the same in a few months. The user experience is significantly better than, for example, with AEM SAML. And also even the implementation complexity is lower than with AEM SAML. Even though caching is tricky in EDS, it's also very tricky if you cache protected pages on AEM Dispatcher. That was it. Thanks a lot.
Thank you.
Thank you. Now we are aware how to protect our valuable content. Like, as you showed, it works pretty well for EDS. Bring your own CDN. Any way to do it with like Adobe managed CDN, like the Fastly on our AEM as a cloud service?
Well, AEM as a cloud service would not go to EDS, right?
No, that would be different.
Okay,
yeah.
Yeah, that's a different route. We did not investigate Fastly, but from what I know, Fastly also provides edge function, and there will be some way of achieving the same thing, I'm pretty sure.
Then there were like similar questions, like all around you have like a single page, but you have like dedicated blocks, content areas, which different restriction. Probably you have public content, and then you have restriction content. Would that also work? Like,
not if you load them in one HTTP request. I guess you have to load them asynchronously, like you would do on a personalization. Sometimes, like you load different experiences. As soon as it's a different HTTP request, you can enforce the access per fragment.
So we have to do several requests.
Yes, yes.
All right. Okay, the next one I have to read. It's a long one. When you change the header spreadsheet in EDS, will this flush the CDN cache, or do you ensure that the page that is moved from public to member gets blocked from visitors that have seen it previously?
Well, that would be your standard configuration. But anyway, if you have a CDN caching and you have maybe an expiration time of 15 minutes, it would take these 15 minutes until your membership level has actually changed. Yeah, I guess it would not change immediately unless you actually know how to flush it or you have some setup. I guess a typical EDS configuration also flushes the CDN for this resource. So I guess it would be doable if that's really a requirement.
Makes sense. Thanks, Ben and Ratko, for having you on stage.
Thank you. Thank you.